Today we'll be solving High Cards Win, a USACO problem from 2015 rated for silver. So this problem is basically about, Bessie is playing against Elsie in a card game where the highest card wins. Bessie wants to know what's the maximum number of points that she can earn. The input is as follows. N representing the cards that Elsie has. Then the cards that would be played in order will be played in the order indicated by the input. Also, the cards are labeled 1 to 2N. And Bessie has the cards that Elsie doesn't have. N can be up to 50,000, meaning at most we can have O of N squared time, because any higher than that will probably go into time limit exceeded for the worst case scenario. So, how am I going to solve this? So first of all, we know what Elsie has, Bessie doesn't have, which also means that whatever Elsie doesn't have, Bessie has. So we can figure out Bessie's cards by figuring out what Elsie doesn't have. So if Elsie has 2, 1, 6, and 4, that is Bessie has 2, 3, and 5. Next, since we want to find the maximum number of points Bessie can score, we want to use the minimum card just to beat one of Elsie's cards. We also want to prioritize Elsie's lower cards first because those are easier to beat, and it allows us just to use our minimum cards more effectively. So for example, we have Elsie's card is at 1. The smallest card that can beat that is 2. So 2 will beat 1, giving her 1 point. Next, there's no card that can beat 6, so we'll leave it as B. Then for 4, the smallest card that can beat 4 is 5, which adds another point, which is 2. So, how are we going to implement this? First of all, we have N, which is as stated as the input in the problem. We used a used Boolean array with n times 1 plus 1 because the input goes from, you can have 1 to 2n. Those are the numbers. So that way this makes it 1 indexed rather than 0 indexed, as the 0 one will be completely ignored, and we can go up to 2n. Next, we label whatever Elsie has as stated in the input as true. Next, we have Bessie and Elsie array lists, just to indicate what cards each of them have. Then we run back through the used array. If the ith card is used, then Elsie has it. Else, Bessie has it. Also, like I said, we had to start the array at 1 because the cards start at 1, not 0. Then we sort both of them because we want to find Elsie's lowest cards because we want to beat those first and prioritize those, as I said earlier. And then we sort Bessie's cards so that way we can find the minimum card needed to beat Elsie's cards. So ants is equal to 0. That's our answer that we're going to print out at the end. Elsie next. That's going to represent the lowest card that Elsie has that hasn't been beaten yet. Next, we're going to go for each of Bessie's cards. If Bessie's card is greater than Elsie's lowest card that hasn't been beaten yet, we increment ants by 1, and then we go to the next lowest card that Elsie has. We repeat this until we run out of Bessie's cards, and then we're going to print out the answer. As you see, oh wait, 3, 1, 6, 4. As you see, the output matches, and we have solved this problem.